Welcome to Math with EJD. In this video, I'm talking about method of variation of parameters for non-homogeneous linear systems. We've been talking about this all along. I've made two previous videos where I focused on using method of undetermined coefficients to solve non-homogeneous linear systems. So here, let's go for this. The method of variation of parameters is a technique used to find a particular solution to a non-homogeneous linear system of differential equations. Okay, consider the system x prime equals ax plus f of t, because this is a typical non-homogeneous system where A is an n by n matrix with continuous entries. Okay, then f of t and f of t is a given non-homogeneous term, which is also known as the forcing term. So that simply means that, the system is getting some external push. There's an exertion, a forcing from outside on the system. That's what the non-homogeneous part means. So to solve this, you have the first step where you solve the homogeneous system. As usual, solve the homogeneous system. And it can be quite elaborate. So the first thing you do is first solve the associated homogeneous system. So that's the term without the forcing term. That's x prime equals ax without the forcing term. So if we say let x1, x2 up to xn be a fundamental set of solutions, a fundamental set of solutions forming the fundamental matrix, forming the fundamental matrix. So it's forming a fundamental matrix phi of t, which is equal to xi, x2, all the way down to xn. Okay. So we say where, or better still, I think this is a better way to represent it. That is x1, x2, all the way down to xn. Okay. So each xi is a column vector solution, Okay. So that takes us to step 2. So in step 2 now, we have to assume a particular solution. Now, this one bears a bit of resemblance with method of undetermined coefficients, except that here we are not talking about it's in a sense the coefficients are not known, but the approach is just different. The approach of getting them will just be different. So assume a particular solution, just like we used to assume for undetermined coefficients. So, but not exactly following the pattern of exponential, polynomial, and trigonometry. So for the non-homogeneous system, for the non-homogeneous system, assume a particular solution of the form xp of t equals phi of t u of t. Phi of t, u of t. So u of t is the new thing that is coming here. We already know phi of t. Where u of t now is an unknown vector. It's an unknown vector function to be determined. So it's more like the undetermined coefficients we have over there, except that the approach of getting this is different. And the fact that this is more generalizable to any kind of function instead of the typical exponential, polynomial, and trigonometric expressions we have for undetermined coefficients. Okay, so this leads us to step 3. In step 3, that's where we look for these coefficients. We compute the u of t, as many as there might be. And the way to do that is we refer back to xp, which is phi of t ut, okay? So then we differentiate xp prime is equal to phi prime of t u of t, right? Plus phi of t u prime of t. That's function of a function. We've seen this kind of thing before when we're talking about undetermined coefficients for second order, I think. So if we substitute, so substituting into the original system, okay. So this is the derivative here, right here now, right? So it means we have what we have up there is phi prime of t u of t plus phi of t u prime of t equals the right hand side. That's ax, right, so to speak, and that will be phi a phi of t u of t plus the forcing term f of t. So usually, right, we have to have xp prime of t equals ax p, right? And now xp is this phi of t u of t plus the forcing term f of t. So following this pattern now, we have that long one down there, okay? Following this now, we have this, okay? So with this done now, so with this, we can then proceed to say, since phi prime of t is the same thing as a phi prime of t. That's from the homogeneous system. From the homogeneous system, that's the idea. From the homogeneous system. So this simplifies to now a phi of t u of t plus phi of t u prime of t, okay? Because now phi prime of t is a phi of t u of t, and this is now equal to a phi of t u of t plus f of t, like that. And in that case, um, we can easily cross out this. Oh, I think we can cancel, right? So from this expression now, you can see that this can cancel this out. So we have a more simplified system. So it's a canceling the a phi of t u of t terms, as you can see up there, right? If we cancel them, then we have phi of t. Then we have, right, phi of t u prime of t equals the forcing term f of t. Easy peasy. And then we can solve, right? We can solve for u of t. Okay, solving for u prime of t. See what we get. We simply have, since we're looking for u prime of t, so u prime of t is equal to the inverse, phi inverse of t multiplied by f of t. Okay, we have this. That is u prime of t. Then we can integrate because we are looking for u of t. So integrating now gives us what we are really looking for. That is u of t. And, to get u prime of t, u of t will now be integral of u prime of t dt. And that's the same thing as integral of phi inverse of t f of t dt. Lovely to get there. Then we go for step 3. Is it step 4 now? I think it should be step 4. So in step 4, we obtain the general solution. Obtain the general solution. Okay. So the general solution to the system is x of t equals phi of t multiplied by c. That's that constant, right? Plus phi of t integral phi inverse of t f of t dt. Something like this. Let me even see. For the non-homogeneous term, right? Did we do anything to... Yeah, okay, that's just phi of t, right? So this is what we have. So of course here, where c is an arbitrary, it is an arbitrary constant vector. Okay. Now let's switch gears as we move on to take a worked example. So example, let's take a simple example where we get to solve x prime equals 1203 x plus e raised to power t, and t down here. That's what we want to solve. And we go straight to it in step 1. Okay, I thought I'd change this. So this is step 1. So in step 1, we solve the homogeneous system. Solve the homogeneous system. So, and the homogeneous system is simply x prime equals 1203x. Okay, that's the homogeneous system like that. So, and for that now, the characteristic equation of A is the determinant of A minus lambda I equals 1 minus lambda 2, 0, 3 minus lambda, and all of this is equal to 0. So that means we can multiply this. That's 1 minus lambda into 3 minus lambda, then minus 2 times 0 equals 0, like that. So we can multiply this out. Okay, in fact, this is 0, right? So we just have 1 minus lambda into 3 minus lambda. There's no point wasting time with this. So we just know that lambda 1 is equal to 1 from here, and then lambda 2 is equal to 3. So these are the eigenvalues, okay? These are the eigenvalues. So eigenvalues, okay? So the next thing we want to do is to find the corresponding, or better still, okay, let me go this way. To find the corresponding eigenvectors, to find the corresponding eigenvectors. So we now have to do that for each of the eigenvalues. So for lambda, 1, which is equal to 1 in that case, right? For lambda 1, which is equal to 1. So we just have a minus lambda I. And since lambda is 1, so we have a minus I, vi, okay? So vi, that will simply be equal to, okay, um, so we subtract 1 along the diagonal from the original thing. So we have, okay, I guess I don't want to jump. Let me just do this. So this will be A itself, that is 1203 minus 1001. Okay. All of that into the V's, right? So let's call this V's now. So let's say V1 1 and V1 2, and that is equal to 0 0, like we've always done. So here now we have 1 minus 1, 0, 2 minus 0, 2, 0 minus 0, 0, 3 minus 1, 2. And that into V1, 1, V1, 2 equals 0, 0. So this is just easy. We see already that we just have, so we have, okay, V1, 1, V1, 2, V1, 1, V1, 2, twice, V1, 1, V1, 2. So you just put 0, 2, 0, 2 like this, and that is equal to 0, 0. And from there, we just have V1, 2, 2, 2V1, 2 is equal to 0. And down here also, 2V1, 2 is equal to 0. That simply implies that V1, 2 is 0. So V1, 1 seems to be missing an action in a way. So in that case now, it means that let me see. So 0, 2v1, 2, 0, 2v1, 2, exactly the same kind of trend. So if v1, 2 is equal to 0, then we can just take v1 because so we can just say let v1, 1 be equal to 1 because there's no way to get it, right? So we just take v1, 1 to be 1 and v1, 2 is 0 easily. So so v1 is equal to 1, 0. Okay, we have that. Then for next we have for lambda 2, which is equal to 3 that we also got. So we have a minus 3i v2 equals now again a is 1203, okay, minus 3003 into now v2, right? That's v21, v22. All of this equals 0, 0. Okay. Okay. So from there, we now have 1 minus 3, that's minus 2. 2 minus 0. 1 minus 3 is minus 2. 2 minus 0 is 2. 0 minus 0 is 0. 3 minus 3 is 0. Okay. And that into v21, v22 equals 0, 0. So we can have v21, v22 twice, v21, v22. So this is minus 2, 2, and this is 0, 0. Interestingly so. And this is just 0, 0 down here. So this is minus 2v21 plus 2v22 equals 0. So for the other one, nothing. So we can use only this one. So 2v22 is simply equal to 2v21. So that means v22 is equal to v21. So in all, v1 is simply the same thing as 1 to 1, basically. So, and any multiple of this can also do the job. So we have our two, we have those two now. So with this now, we can say that thus the fundamental matrix, is phi of t, which is so it's like we have 1, 0 for the first eigenvalue. Okay, let me do it this way. So that's like just like we said the other time, right? We talked about the solutions. So it's more like we have V1, V2, e raised to power t, something like this. So that means that phi of t is equal to V1 is 1, 0, V2 is 1, 1, then 1, 1, right? Mm, okay. Okay. I guess let's go carefully, right? So if we look at the eigenspaces, we need to consider the eigenspace, right? So this one is we have the eigenvalue. So we have for this, I'm trying to look for a nice way to do this. Okay, let's do it this way. So for the first one, right, we have the eigenvalue was 1 and the eigenspace was 1, 0. I mean the eigen vectors. Then the second one we have eigenvalue 3 and the eigenvectors 1, 1. Okay, something like this. So so it's connected with this basically. So phi of t will be based on this. So it means phi of t now is equal to um so we have one we have 1, 0 e raised to power 1, this one now t, then the other one we have 1, 1 e raised to power, okay, we are not adding up, sorry, we're just going to occupy different spaces. So this is 3t because of the eigen. uh Okay, I'm looking for a very nice way to present. This is correct, right? But I just want to I want to get a very methodical way of representing it at the end of the day. So arriving at the final result would be so cool. Okay, so let me just go straight here. Let me do this. So this has got to be V1, okay, e raised to power lambda 1 t. Great, I think I like this. Then V2, e raised to power lambda 2 t, basically. That's, yeah, I think this is more like what I want to do systematically. So we now have, so since we know that lambda 1, lambda 1, lambda 2 is the same thing as 1, 3, and then V1, V2 is the same as 1, 0, 1, 1. Okay, so using this now, we can say so phi of t is basically so phi of 2 is 1, 0 e raised power t, okay, because of this one now. Then plus 1, 1 e raised power 3t because of this 3. So this 1, 0 comes here. Then this 1 is here. Then this 1, 1 is here. Okay. And then this 3 is from here. So we can have it neatly this way now. Okay, I mean e raised power 3t, and that goes. So we can just tidy that up. So phi of t is simply e raised power t, 0 here, then e raised power 3t, e raised power 3t, basically. And this is our complementary solution or homogeneous solution. So that goes. So the next thing we want to do, I guess I also want to switch gear here. Say I now have this, and then I have to use blue this time around, or even the other one. Okay, so if I use this now, or let me use this. So step 2 now, in step 2, we want to compute u of t. Compute u of t. So in that case, we solve u prime of t is equal to 5 inverse of t, u of t. Okay, u of t. So we are looking for u of t basically. So the first thing we want to do is to compute. So first compute phi inverse, compute phi inverse of t. We already know phi inverse. This is it here. Okay. So I think that's pretty easy to know that phi inverse of t is simply equal to, so the phi inverse we had already is e raised power t0, e raised power 3t, e raised power 3t. The inverse of this, being a 2 by 2 matrix, it's pretty easy to handle this because all you just need to do is to do some switching. Okay, we know the determinant first of all, right? So if we find the determinant, that okay, I guess I need a bit of space here. Okay, so phi inverse of t is equal to 1 over the determinant of it. That's 1 over, to find the determinant, that is e raised power 3t times 3t. So that's e raised power 4t, okay, minus 0 times that. So that's minus 0. All of that into, then we now do some switching. So we do some switching over. So we change the signs here. I'm trying to see, what do we do? Okay. Oh, sorry. What we have here, sorry. This is actually f of t. The f of t we had initially. This is f of t. Don't forget this f of t. So, to take care of this, right? This is e raised to power 4t, and then okay. So we switch this over, and then we have e raised to power 3t here. Okay. We have e raised power 3t here, then e raised power t comes here. So we switch these two over. We switch them over, and then we change the signs for this. So of course, 0 remains 0, but this e raised power minus 3t now. E raised power 3t becomes minus e raised power 3t. That's how to find the inverse for 2 by 2. So the numbers on the principal diagonal, you switch them over, and then you change the sign for the other diagonal, and then you also divide by the determinant. So we now have phi inverse of t to be equal to 1 over e raised power 1 over e raised power 4t into e raised power 3t, okay, minus e raised power 3t, then 0 e raised to power t. So we can tidy things up there. We have phi inverse of t equals e raised power 3t over e raised power 4t, then minus e raised power 3t all over e raised power 4t, then 0 over e raised power 4t, and then here e raised power t, e raised power 4t. So we can have this, and this is phi inverse of t equals, here we have e raised power minus t, and here that's minus e raised power minus t, 0 here, and this is e raised power minus 3t. So that is phi inverse of t from all what we have all along. So we go on, and we're looking for, so we can say, so phi prime of t, which is u prime of t, which is phi inverse of t multiplied by f of t, the forcing term, will just be u prime of t equals what we have now, e raised power minus t minus e raised power minus t, 0 e raised power minus 3t times the forcing term, which is e raised power t. That's from the original problem, from the very original problem. I think that's from the original problem. Yeah, that's from here. This is the forcing term. So e raised power t, and that's and t now. So we move on to deal with that. And what happens there is this. We have u prime of t. Okay, I guess I want to switch gears again. I want to change marker. That is. So let's do this. We can write this twice. So u prime of t will just be e raised power t. Write it twice, e raised power t. Then you invert the other ones on it. Invert this on it. So e raised power minus t minus e raised power minus t. Then down here we have 0, e raised power minus 3t. Okay, that will be our u prime of t. So u prime of t is equal to, so, e raised power t, e raised power minus t is just 1. Then plus t times e raised power minus t. So that is 1 minus t e raised power minus t there. Then down here, this is 0, and this is t e raised power minus 3t. That is our u prime of t, basically. So since we are looking for u1, we are looking for u of t. So we just integrate. So integrating we can split things up. So we have u1 of t now to be equal to integral of 1 minus t e raised power minus t dt. Okay, we have this now. So to just do that, we have so for this now, integral of t, integrate t, just get t straight up. And then this is more like function of a function. I mean, what is it called now? Um, mm, inte integration by parts. Yes, I think it's integration by parts. So we have this now, minus, this is minus. So this is like you want to integrate, the one that can be easily differentiated is u, and this is dv, so to speak. So that would be integral of, you want to integrate u dv. So integral of u dv is equal to v du. So that's v du. All right. Okay. Yeah, I'm just trying to do that without stress. So integral of u dv is v du, and an integral of v. Okay, yeah. Now I remember that'll be uv for sure. So uv minus integral of v du. Okay, and an integral of v du because of that. Yeah, I think this works. We have already integrated this one, so we just want to take care of the other one. So this is t minus, so u is t already. V is you have e raised power minus t. So if you integrate e raised power minus t, you get v. So if you integrate e raised power minus t, it's going to give you a minus, right? So you just have e raised power minus t all over minus 1 here. Okay. Then minus integral of that v now is still e raised power minus t all over minus 1. Okay. Du, when you differentiate, if u is equal to t, so du is also dt. So this is also, this is just dt also. Du is dt. So we have this now. So I think we can tidy this up. So this is t minus um t minus, you can do this now. This is minus t e raised power minus t. Then this minus and minus can also go. We have plus integral of e raised power minus t dt. Okay. So that is, we're still talking about phi of t, right? Oh, it's now u of t. It's now u of t. Yeah, it's u1 of t we're still talking about. So this is u1 of t, u1 of t now. So u1 of t is equal to t, still minus integral of minus t. Okay, then we can even bring this out already. So t plus t e raised power minus t. Then if we integrate this again, we just have minus e raised power minus t all over minus 1 again, plus some constant which we may not have to worry about. So this is u1 of t, and that is equal to t plus t e raised power minus t, okay, plus e raised power minus t, basically. So that means we have u1 of t to be equal to t plus e raised power minus t is common into t plus 1, okay? That's u1 of t done and dusted. Then we have u2 of t. So for u2 of t, we just pick this second one, right? So so u2 of t now will just be the integral, of u2 of t will be the integral of t e raised power minus 3t, t e raised power minus 3t dt. So we do integration by parts again. So again, our u is t, our dv is e raised power minus 3t. So u2 of t will just be uv minus integral of v du again. So u2, so if you don't understand this, you can check my basic calculus playlist. I've elaborated this one with better explanation. So here u is t, then dv, if you integrate that, just get e raised power, minus 3t all over minus 3, that's our v there, minus integral of same v, which is e raised power minus 3t all over, okay, no, this sign doesn't show up yet. So that's all over minus 3. Then du is just dt, because u is t. Okay, so u2 of t is equal to minus t over 3 e raised to power minus 3t. Minus and minus is plus. Then again, 1 over 3 e raised to power minus 3t. So that is u2 of t right there. Okay, so now we have u of t. So we now compute the particular solution. Okay, what's happening here? Let me see. V. What is V now? V is, yeah, 1 over 3. What's wrong there? What's wrong? What's wrong? What's wrong? Um, minus t over 3. So when we come here, V itself is e raised to minus 3t over minus 3, yes, dt. Okay, I think that this works. That sure works. Yes, it does. Yes, yes, yes. Or is there a mistake I've made? I don't think so. T e raised to minus 3t. So u is t, v is integral of e raised to minus 3t. That's e raised to minus 3t over minus 3, correct? Minus integral of e raised to minus 3t over minus 3, sure. Du is dt, right? Yeah, I think that's fine. Minus t over 3 e raised to minus 3t. Yeah, I guess we're good to go. So now we have our, so we have u itself. So u of t is simply the same thing as what we got up there. That's t plus e raised to minus t into e raised to minus t into t plus 1 up there. Then down here, we have minus t. We have minus t over 3, okay, plus 1 over 3 e raised to minus 3t. So this is our u of t now. This is u of t. That is u of t. So in the next step now, we just compute. So step 3, compute the particular solution. Compute the particular solution. And in this case, the particular solution is the solution we assumed at first. So xp of t is just phi of t u multiplied by u of t. So it means that xp of t is just going to be, so what is our phi of t? You remember it's e raised to power t 0, e raised to power 3t, e raised to power 3t into what we have just got now. That's t, that is t plus e raised to power minus t into t plus 1. Then down here, we have minus t over 3. We have minus t over 3 e raised to power. You can even factorize, right? So it's minus, minus t over 3. Oh, I haven't skipped this. E raised to power minus 3t. E raised to power minus 3t is common. So we can have even that to be e raised to power minus 3t, e raised to power e raised to power minus 3t into into minus t over 3 plus 1 over 3. That's just okay, e raised to power minus 3, or we can even take out the 1 over 3. I want to make it as tidy as possible. Okay, so I can have 1 over 3, okay, 1 over 3 e raised to power minus 3t into, okay, 1 over 3 e raised to power minus 3t into minus t plus 1. That is simply 1 minus t. Okay, I think that's tidier. So we can expand all of this now. Okay, we can expand this. So this is like xp of t equals, so we can write this twice. So we have t plus e raised to power minus t, t plus 1, then 1 over 3 e raised to power minus 3t into 1 minus t. Then we write the same again. We have t plus e raised to power minus t into t plus 1. Then 1 over 3 e raised to power minus 3t into 1 minus t. Then we invert all this over them. So this e raised to power t, this e raised to power 3t. As you can see, then here we have 0 e raised to power 3t. I think I like the 0 part because it cancels out and makes life easier. Okay, so we can then have our xp of t to be equal to, so if we do this, so we have, for the one at the top, we have te raised to power 3t, te raised to power t rather, te raised to power t, then this just cancels out. So e raised to power minus t cancels out. So we just have e raised to power t replacing, oh, okay, this just cancels out. So we have t plus 1, te raised to power t plus t plus 1, okay, plus t plus 1. Lovely. Then when we come down here, e raised to power 3t cancels e raised to power minus 3t. So we have plus 1 over 3, okay, plus 1 over 3 into 1 minus t. That's for the top now. So e raised to power t times t, t e raised to power t, then e raised to power minus t plus, so e raised to power minus t cancels this, so we have just t plus 1 there, then plus e raised to power 3t cancels e raised to power minus 3t, and we just have 1 over 3 into 1 minus 3t. Okay, we can tidy that up later. Then when we come down, this is 0, lovely. And here, e raised to power 3t just cancels e raised to power minus 3t. And we just have 1 over 3. We just have 1 over 3 into 1 minus t. So this is what we have for xp of t. So I can see prospect for tidying things up there. So we have xp of t equals te raised to power t for the first one. Then plus, so this is t. Okay, let me work it out clearly. Plus t plus 1 plus 1 over 3 minus 1 over 3t. Okay, so 1 over 3 times 1, that's 1 over 3, minus 1 over 3t. Then we have 1 over 3 into 1 minus t down here. So I have xp of t. I have xp of t equals, what's this now? Xp of t will now be equal to, okay, I'm going to tidy this up. So this is te raised to power t, then t here. So this is like 3t over 3 minus 1. So that will just be plus 2 over 3t. Then 1 plus 1 over 3, that's plus 4 over 3. And then this is, then when we come down here, 1 over 3 is common. So, I mean, we can leave it just the way it is, right? So that would be 1 over 3 into 1 minus t here. We can still do a bit more. Xp of t equals, here now, we have t is common, so we can have t into e raised to power t plus 2 over 3 plus 4 over 3. Then we have 1 over 3 into 1 minus t. So that's what xp of t is. So finally, we talk about the general solution in step 4. Step 4, general solution. You have the general solution, which is x of t, and that is equal to what we like to call xh of t plus xp of t, which we just got now. So x of t now will just be, if you like, c1 e raised to power t into 1, 0. If you remember, we got that initially. Then c2 e raised to power 3t into 1, 1. Then plus what we just got now, that one that looks plenty. So let me just put it. So we have t into e raised to power t plus 2 over 3 plus 4 over 3 out there. Then down here we have 1 over 3 into 1 minus t. Wow. So that's the general solution using variation of parameters. As usual, don't forget where C1 and C2 are constants. C1 and C2 are constants. So before we go, let's take a practice question. Practice. I think, how many can I give? Okay. Of course, you know you're solving using variation of parameters, right? Okay, I'll just say the following, solve the following. 1, 1, x prime equals 2, 2, 1, 0, 3. Looks like what we just did now. X plus e raised to power t. Then we have sine t down here. Do this using variation of parameters. 2, we have x prime equals 0, 1 minus 1, 0, x plus t e raised to power t. Okay, 3, do this. X prime equals 4 minus 2, 1, 1. Okay, then x plus e raised to power 2t t squared. Okay, number 4, do this to x prime equals 1, 2 minus 3, 4 x plus cos t e raised to power minus t. Do that. Then something a bit more advanced, maybe. Number 5, x prime equals 2, 3 minus 1, 0 into x plus e raised to power t, then t e raised to power t. And lastly, number 6, x prime equals 1 minus 1, 2 minus 2, x plus e raised to power t, e raised to power minus t. Let me see your answers in the comment section, either on Facebook or on YouTube. And let me also know in the comments how helpful these videos are for you. And if you want me to solve a problem or teach it on a particular topic, if you have subscribed to the channel, thank you very much. If you have not subscribed, please go ahead and subscribe. And for everybody, don't forget to hit the notification bell so you can always get alerted each time a new video is released. And finally, be sure to like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.